Some good coffee. All right, we back. Now, we've gone through so many pieces of the 15%, of the simple syntax to the processes we use to organize our code. And we have a little workbench that we've set up here using our JavaScript and HTML knowledge so far. Today, we go into what might be kind of like a complex idea, but it's really not once you already know the first case scenarios, the first bits that we've already done. When we're dealing with, let me check my mic. Okay, good. I've got to make sure my mic is active. Um, when we deal with variables, functions, all those bits and pieces that we've basically run through. Now we can put them together into something called an object. Hello, Scary. What's up, buddy? Welcome in. We're doing one of our sessions, huh? We have variables, we have functions, we have logical loops, all that kind of stuff. But the kind of key here is something called object-oriented programming, OOP. That's the focus. Now, the understandable bit here is that you don't need OOP to program. It's just a recommendation in a way, but it makes programming all the more powerful. So object orientated programming. And that's kind of the key words we're working with here. Orientated programming using objects. We refactor, we create our code to function within these things called objects. The best kind of idea that we can absorb from this is to look around and pick an object of our choice, literally, around us. Let it be a lamp. We take a lamp, maybe the ceiling lamp, or the one on our desk, or even the lamps behind the TV screen or the monitor. There are bits and pieces of what a lamp is that can be described within an object. Whether it is a ceiling fan is one of those cases, or whether it's a desktop lamp that sits on your desk. All of those have a function. They create light. They also have a shape, an X, Y, and or Z coordinated plane, and all kinds of features that describe those objects. So when we think of what actually object-oriented programming is, it's basically the human mind trying to make reality, or what we perceive as reality, a characteristic of our digital frontier of programming. When we take these objects that we can analyze and then say that they have specific types of features, we take that into account and say, hey, how can I make certain objects in my code have those features, or features that can kind of start from a point? So let's say we're going to be doing this little game mechanic here where we create players textually. It's going to be anything fancy. We need a lot of 3D and 2D and all kinds of designing involved. I'm not a designer, I'm more of a, well, programmer. But we're going to make a textual fighting scene game with a bunch of characteristics that we essentially know from our typical programs and games that we play. So in any game, we have a player with stats and certain types of values. So if we wanted to create a type of object that will throw a type of characteristic and maybe give it to multiple players, because in a world of games, in a world of programs, we have certain stats, certain things that exist within all players, like damage, hit points, defense, accuracy, all those kind of values. So we create a class that we create as a blueprint. Hello, 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 Tech Rohit. Welcome in. Now, when we think of a class, it's basically a blueprint. Think of a blueprint that exists in a building schematic. When you want to create a house, you kind of have some kind of values that are pretty specific or pretty obviously everywhere. Bathrooms, kitchens, living rooms. So when we have a blueprint, we're essentially using that blueprint as a guide to create that house. In our case here, we're creating a player blueprint with specific values. Now, apart from the other syntaxes, like a function, functions use the parentheses here to have an input. That input can be modified when we actually use that function as parse input search, throw in some values, and then do some stuff with those values. Here it's kind of empty, so nothing happens. Where did I have one? Yeah, right here. So in our keylogger session, we were able to set up basically a listener for the keyboard. And that keyboard key press detect function is right here. Now, automatically in JavaScript, that key press detect function throws in a key value. So every time you press a key on your keyboard, that key gets passed inside of this input. Then we can scan that, get the code of the key, and then actually test to see what value that key contains. So basically which keyboard key you pressed. And when we, let's say, detect an enter, we can activate the button click function that was technically reserved for this button here, which will activate the process in between, getting it started. From here, we can actually activate this button click function with the enter button on the keyboard, which basically gives us the ability to bind a keyboard key to a function like a button press. Now, in this case, button click wouldn't really be the best like naming convention, but since we started it off in the beginning with this, we don't really want to change the name since it kind of contains most of our code already, which shouldn't be too crazy if we decided to change it, but it's not accurate anymore for it to be a button click since we're using the enter key to actually enter the value. But the important part is this input space. When we have a key being inputted, we can now scan that key and use it within the function itself. Classes do not have this particular regular smooth parentheses. What they do have, however, is a container, a curly brace space, where I would like to call the code block. The code block itself is going to basically give us details about this blueprint. What do we want the blueprint to contain? Well, in a gaming environment, we want a couple of values, a couple of things that all players should have. We have essentially hit points. We can set it up to a specific value. We should have as a player in a game attack points. Set it up to a specific value. We'll have defense, set that up to a specific value. And of course, accuracy. And we'll set that up to a also specific value. Mathematics is going to play a decent role here since we are playing with numbers to have a fight scene and a duel between two players. Now, the key here is this blueprint just contains these specific values. And when we want to give these values to any other object in our list, we create a player. Or we say let player 1 equals to new player. That creates our player 1 value. Now we can't fight without two players, so we'll make a player 2. And of course, we can also throw in a name in here. A little bit extra on that. We'll have to create a kind of startup function, but for now, we'll keep it like this, learning it piece by piece. Now, we are using the same blueprint twice for both player 1 and player 2. And with that in mind, we're essentially making a copy of these values within each one of these variables. From there, well, there's a case for building the fight scene. The important part really to get our minds across when it comes to these objects and classes. Right now, the blueprint is our class, and these player 1 and player 2s are the actual objects manifested, the created objects from the blueprint. When that happens, again, we only basically use the given information, throw it into those variables, and then go about our day. From there, we can now start using values within. This part is important because we don't just use it here within our own class, but you will notice that this pattern exists in the existing code we have already done. If I wanted to, let's say, check for some values, like player one dot hit points, this is how we access the values inside of the object. It is the dot notation. For variables or attributes inside of our class, we use the dot hit points. We don't have functions yet, methods, but we will create some as well. This notation, though, has been used multiple times in our previous processes, including document.getElementById. This is how we access internal values of existing functions or objects, or the functions that exist inside of those objects. The great thing about object-oriented programming is it's very organized, and you can use other people's code within yours, or essentially other libraries, by getting to understand, basically, the process. How to dive inside of a document and do some functioning processing inside. Here's another case, dot value. Dot value is just going to essentially grab the value of the user input ID, which in our case was our input right here. And in the visual sense of things, it's just this input box right there. So the case here is that when you kind of level up to this object-oriented format, you're able to not only create organized code that you can share with other developers, and this is really in a work environment. When you're working with a group of other developers, this is really how you're going to code. You're not going to just do functions, just do variables and lists and arrays and all that kind of jazz. You're going all the way in and creating objects. Not only that, you're documenting it, which is interesting because now at that point, you create your own guides and tutorials for other developers to understand how the, let's say, player class works, how they can access specific values inside of that player class. Now, I haven't done anything crazy so far. So if I just refresh and go to inspect, go to my console. Oh, there we go. Close this out. Hit points are 100. That's all it's doing. We haven't really organized this within our space here of our system, right? We have a if-else search. We didn't really press a button to activate this. It just started working because it's on the root level of our code. It's not really bind or contained within a block of code. Now, if I wanted to basically clean this up a little bit, I'll go ahead and create a function for this case scenario. I will grab the code I have here, cut it, paste it within my function, and give it a little bit of organization here because the cutting pasting doesn't always work. Also, a good little tip here, anytime you want to refactor, you can go into the refactoring space and this will clean up your code or format document here. This will do the automatic kind of spacing tabs and everything, so you don't have to worry about kind of messing up your format. So this is a very useful way to clean up code automatically by Visual Studio's standards or the general language you're using currently. So now, if I refresh and I do go here, we don't have the 100 pop up because we haven't activated that battle sequence. Then we go into our if-else statements, and let's add that specific function to our list of activators. So we'll grab our command array, grab the first index, give it a 2 lowercase, so we don't have to worry about case sensitivity. And then let's just throw in battle with our command arrow, just to keep that organized. Let me close this off to the side. And we created the function called battle. So let's start the battle right there. Now I can refresh, throw in battle, press me, bam. We got that 100 pop up. So we can confirm that this is running. We are creating our class player. And then we are detailing the association between player 1, player 2, and now being activated like so with the new player class activator. So new is a keyword used specifically when you want to turn a blueprint into a set of code that you want to save into a variable, an object. Now, from here is the process of creating the battle scene, the turn by turn or the turn-based strategy sort of factor, right? One person attacks, the other person defends, and then they swap and back and forth. Here, we have the option to basically do this directly within the class, so we are going to populate the class further with methods, functions that exist within these class that will basically, function as the player process of battling. But we can also build them on the outside, just for the case of learning the process. So the logic here is now based on mathematics. We have to do a couple of tests and a couple of bits and pieces for us to set a battle scene. In the case for the first stage, let's say player 1 attacks player 2, which means player two's hit points are going to change. So we can set up a very quick format, player 2 dot hit points will change. So we set it equal. Very straightforward process. We're changing player two's hit points based on the current player two hit points minus player one dot attack. And then we will print out player two's hit points here as a first swipe or first attack process. And then we do battle again. Boom, 95. So player 2 now has 95 hit points. Player 1 being the player 1, the first player on the controller of your GameCube console. For some reason, they always get the first turn, but this is the typical sequence process. Then player 2 responds by grabbing or we save the new set of hit points for player 1 by grabbing his current hit points. So we can kind of double dip on that variable. And then, of course, just doing the opposite. This time, player two's attack is going to activate this case scenario. We haven't talked about accuracy, defense, and all the other factors just yet. Then I can do a little bit of a detail here. So player 2 HP, and then player 1 HP. Or let's do it backwards. Player 1 first, player 2 second. Bam. So now it's pretty even. If we continue this process, what do? We just basically copy and paste, 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 right? That's your typical, well, level one train of thought. What we do actually want to do is, since we know this is a repetitive set of code, this is where we can start creating the continuous loop that happens until someone gets to zero. So we make the particular check, logical check, while something happens, keep the battle going. And what is it that has to happen? Well, player 2 or player 1 dot hit points equals to or does not equal to 0. How about that? We have to do a not equals case. In the case of comparing logical values, exclamation mark equals is just a not format. It's an opposite of an equals. If it's not equal, continue. If it is equal, stop. In fact, it might be a little bit weird here using the specific equal value because at some point we may have certain changes to our code that will get our points to -1 or 2. So class is basically a set of rules for objects, correct? A class is more like a definition, right? You can essentially define details of an object. You can call them rules for sure. In our case, so far just values. But we will go into, well, this battle scene we're creating here outside of the class. We're going to have to kind of incorporate it within the class itself. We got to give that class the full control of the battle rather than putting it outside. For now, we're seeing how accessing player 2 hit points works from the outside and player 1 hit points works from the outside. This is a key difference that we're going to see later, because there's going to be certain keywords we use inside of class, which will kind of boggle the mind a little bit. But once you get the idea of relativity, like player one is relative to itself, so player one contains these. And when player one becomes 95, let's say we remove this case scenario. In fact, let's kind of comment this out real quick. So let's go back to just a single hit, right? Player two hit points change. So what happens? Player two, refresh, battle. Notice player two's hit points are 95. This is the relativity of these objects. But player one hasn't been hit yet. We've commented out the code for player one's change of hit points. So this is really where it starts to get a little bit mind-boggling. How can the same class act on two different players differently? Well, because in essence, we're creating two totally different copies of that class, manifesting it into an object, and then saving it in player one and player two. So whenever player two's values change, player one does not change. They are disconnected at that point. Yeah, that's fair. Can you give an example for these of class and object? So this is the case here. Once we get to the this keyword, this is the case. This keyword, it's going to be a little bit of a mind boggle here, but the this keyword uh, implies relativity based on where it's being called and who is the kind of object calling it, right? So right now, if the case for we don't have a this, we're going to take it slow because that is where the confusion happens. Absolutely where the confusion happens when we start talking about the this keyword. And then inheritance and everything else comes down the road. But for now, consider this factor here. We had only player 2 get hit points taken. Therefore, only player 2 is its own value, as its own object, decreased its hit points. Player 1 still has 100. Nothing has happened to player 1 just yet. We've commented it out. It's not really happening. But we did make a copy here for that one particular player 2 to take away that hit points from player 1, the attack of 5. So this is the result here. Now, if I grab the player 1 code, so player 1 hit points changed now because of the equal sign association, and I refresh. This is why taking it step at a time is going to be important here because these sort of class abstractions become a bit confusing. Now you can see that both of them have 95. Now we actually have a change to player one's hit points. In this case, player one is the this keyword. But then again, over here in player two, that has its own this keyword. Like, you know, relatively between these two different objects because they exist in two different spaces of memory, put it that way. They exist in two different spaces of memory, but they are blueprinted. This is why it's really important to think of a class as a blueprint. You can make a house, you can make 10 houses from a single blueprint, right? You just have to draw out where the rooms are, where the kitchen is, and when you do that, you make 10 houses that look exactly the same. That's why a blueprint case mentality is important to wrap around the class idea. What is a class? It is a blueprint. You can make as many objects as you want with that blueprint. But if one of those houses has a fire, does that mean every house burns down? No. Only one object gets affected, while the other ones have their own relative space that, if they didn't have a fire, why would they burn down? So when we're really thinking about this class to object relationship, it's that again, a class is a blueprint. It's basically just how we want something to be, like you said, rules, right? That's what you said, Scary. Rules that we have for a specific way we want it to format. And the rules are it has hit points, it has attack, it has defense, it has accuracy, and a name that we haven't quite talked about yet. But that's the idea. And then those rules are applied to a variable. The first house we build, house one, right? Exact same kitchen, exact same whatever, bathroom. And then house two is created that has the same factors and the same bits and pieces. house 3, house 4, however many houses we want to make from this blueprint, they'll essentially just kind of look the same until one of them has a fire, but doesn't mean that all of them are burning down. Cool. Okay, carrying on. So now, since we kind of have the layout of the kind of battle scene, right? Player one or player two gets attacked and their hit points change based on the initial amount of hit points minus the attack. And then afterwards, player one gets a hit from their initial amount of hit points, and then player two's attack. We basically say, okay, that's scene one. This is event one, but what if we want to essentially now expand it into an actual battle scene? So first, we have to have an endpoint. The first endpoint is when player one hit points is equal or not equal to zero. But again, when we deal with defense, when we deal with accuracy, some attacks might miss. We might even consider criticals, right? Critical hits. 10% chance for a critical hit. So maybe it's not going to be an exact number of 5, but 5 times 0.1 or would be added to the attack, which basically gives you a critical hit. So we're not really sure the values that might happen within a more advanced version of this battle scene. Right now, player one attack is just a pure number 5. So yeah, we can of course relate and go down to the level that 5 from 100 is 95, and then 90, and then 85, and then 50, and then 45, and then 10, and then 5, and then 0. And we can stop at 0 comfortably because we didn't really do anything extra. But for the case of not equals to 0, this really is interesting because if you actually go from maybe a critical hit and you have 4 hit points, and then it goes 5 below, now you're at -1. So you will keep fighting even though you're negative hit points with this logic. This is kind of an interesting case to really realize your logic is important to really get every single case that might happen. If you have a -1 at some point, you've already passed 0, and this condition never gets met, and then we just keep fighting into the negative infinities, and lo and behold, you create an infinite loop that never ends. And we don't want that. We don't want an infinite loop. The best case here is for me to show you, but I think that logic there pretty much makes sense. But now on the other hand, not only does player one's hit points cannot equal to 0, I'll keep it like this, but I will let you know we will have to change it. But we want to check player two dot hit points and make sure that his player points are hit points are less than, or less than would be the appropriate way to do it. Not equal to 0 is the beginning steps to getting this to work. So both players cannot have a 0 hit point. And when this happens, we go all the way through. We're going to have a battle scene. Let's go ahead and we're going to kind of have to go over here, grab this, put the console log in the loop so we can see what's actually happening here. And then we refresh, battle it up, and there's your sequence of events. 95, 95, 90, 90. They both change piece by piece. But the weird part is, player one's HP is 0, and then somehow he still attacks player two and gets his HP to 0 too. So there's logical kind of adjustments we have to make, but obviously the loop for the battle is pretty sound. We don't really have a winner. In fact, somehow player one came out from the dead and destroyed player two anyway, so there's a logical error that we're having here. We're still attacking when there's a character that's dead. Case for that logical adjustment. Now, if that was the case, right, we got to make sure that when the player attacks, they have greater than 0 hit points. So we do some if statements. So since player 1 is on the attack, we got to make sure he's alive. Player 1 greater than 0 hit points because he can't attack if he's dead, right? I hope so. It'll be a weird game. But then again, I guess Necromancy and Diablo and all kinds of weird stuff can happen. Maybe he sends out a burst nova on death and kills the other player. I don't know. All kind of features you will add on to your gameplay. But here, now we check first if player 1 has a greater than 0 hit point value, and then we make the attack. In this case, for the next situation, we're subtracting from player one's attack, and we do the same thing. Player 2, or player two's attack, so we do the same thing. We check for player 2 being alive, and then we can go ahead and make that fight or that attack happen. Now we might have a different result. We should have a different result. We absolutely will. Battle. Enter. Oh, problem. Let's see what happened. So hit points, oh, player one. I didn't put hit points. It's a human problem. So I have to make sure I'm using the hit point value. It's not automatically going to say, hey, what's player one's greater than hit points? We have to make sure we specify what value inside of player one object we're looking for. And in this case, it was hit points. Small error, fixed real quick. Oh no, I've created an infinite loop. Hey, look at that. This is how an infinite loop looks like, guys. It goes on, and let's see what the processor is doing right now. Uh, it's going. Holy moly. It's taking up 3.7 gigabytes of space, and if it gets to if it gets to the end, I will eventually crash. You can see it's going on forever up here. It's just rolling on, thinking and thinking on that loop. That loop just keeps going. So I'm probably I can't even close it. I can't change it. I can't refresh. I gotta close the browser and then start over. So there is your infinite loop that will definitely happen once in a while. If it does happen, Task Manager is the best way to kill it. If it's, not in the browser. In the browser, just close that tab, open it up again, and then do it one more time. Oh, wait a minute. Wait a minute. Did I do it again? I don't have the console open. Uh-oh. I'm actually crashing. Uh-oh, guys. Hold on, hold on, hold on. Uh, 1 second. 1 second. 1 second. 1 second. What are we doing? What are we doing? I can't see what's happening, so I can't even vouch for why it's happening. All right, let's do. Okay, it closed. It closed. We're okay. Hit points greater than zero, less than zero, subtraction. All right, let me actually see what's happening here. Because I gotta see the loop itself so I can make sure that I gotta make sure I put up the console. There it is. All right. And programming comes with debugging, so yes, look at that. We're below negatives this time. This is the case that's bad. So what's my bad thing? What did I mess up on? I'm specifically looking for a zero when somehow this player now has negative 1 million hit points. Let's. I kind of warned this, I kind of warned you of that error. So let's go back. So what's the correct way of not using this case? It's to make, hey, if player one has less than zero hit points, we don't want it to be negative. In fact, we kind of don't want it to be negative or equal zero. So less than equal, less than equal. This will fix that error. So now anytime we get to this case scenario, make sure to refresh because I'm not using the new code. End up in an infinite loop again. So less than equal to zero now with, let's just get the console open so I can see what's happening. Um, press. Issues. No, it's not. No, it's not. Oh, it's not frozen. Something's trippy. Greater than, less than, or equal to? What's up? Normally, you'd have a type of... Hold on, why are all these things popping up? Okay, well, I can activate battle this way too. Oh, let's see. Did I mess up a association? So now I gotta check some. Boom. That's condensed. Fine. Class is condensed. Fine. Function battle is condensed. Fine. So why is this undefined? Function battle should not be undefined. Actually, it's not. So if I try to run it, so the two different ways to kind of really work with functions, if you use battle without the parentheses, it's actually going to show you the code of that. Okay, stop doing that. But if you use it with parentheses, it's going to activate the code itself without the actual visual showing. So that's kind of a small JavaScript specific detail. So for some reason, maybe I have an error here. Let's do less than. I think like that. Player 2 hit points less than zero, less than zero. Okay, let me adjust that. Nani? Okay, let's go back because this was working fine here. So if this was working fine, what happened that messed it up? I'm gonna infinitely loop again. That's working fine. Close. Okay. So that works fine, but the less than doesn't work. That's an oddity. I'm doing something incorrect. Now, the case for the up horizontal values or the vertical lines here, the vertical lines are basically just a logical operator for the keyword or. So either this will be true or that will be true. Either one case scenario is going to actually bear a true loop and keep going. If both of them are false, and this is kind of where discrete mathematics comes in, all right? So we have a couple of options here. Uh, Player one hit points can be true, and then player two hit points can be true. They're both less than zero. Therefore, the outcome is true. We can also have player one hit points equals to true, but player two still has greater than zero hit points. Oh, wait. We have to be in the loop only if we have greater. They're dead if they have not equal. Yeah. So while their hit points are positive, it's a brain logic thing right now. While the hit points are positive, keep going into the battle. All right. So we've got true equals true. True, false for the OR case is also equal to true. You can reverse that and say false, true is also equal to true. Now, the only case for it to be false is if both of them are false. So this is one of those truth tables you'll see in discrete mathematics, right? The truth of something happening and whether the OR operator here is going to work it this way. There's also an AND operator, which we'll see in the future when that type of logic is applicable. But for now, we're really dealing with this case being if player one has greater than zero hit points, think about that. He's got 5, 10, 50, he can still fight. Okay, logically makes sense. Player two also has greater. So I think that's what my issue was. It wasn't actually running the loop because, uh-oh. Okay, at least it's running the loop. I can feel it. I can feel it in the processing. Hold on. Uh-oh. Come on. There you are. Okay, now I gotta check the console, see why this is not happening. Still going. Wait. Oh, right. I think the or is the worst case scenario, actually. Actually, a good learning lesson here. Because player one still has 5 hit points, he's still hitting he's still hitting player two. He's like literally beating the dead body right now. Hold on. This is where we actually need and see, this is not on by accident. This is on purpose for educational purposes. So we actually need both players to be alive in order to have a battle scene. Isn't that logical? All right. So then what's the other case, right? Let's take a look at the and key. So double ampersand for and, which means true ampersand true is equal to true. And remember, loops work in this way. Oops. Loops work in this way where this whole thing is going to end up either being true or false. That's really the only time this comes down to this, right? So in this case, we want true to be the while loop to be true in order to continuously go through that loop. If it turns even slightly false, it breaks out of the loop and then we continue with the code on the outside. But in this case, this whole, one might say, is a algorithm. It's a mathematical problem. The computer is trying to figure out whether this that pertains to this side. That's what they always say as teachers. Oh, this wasn't a mistake. This was a learning opportunity. So they say, all right, if this is true, and then this is also true, which means then the whole loop is true. So we go and repeat the battle scene. However, what are the other options? If we have true ampersand false, that's false, means stop the loop. If we have false ampersand true, that's also false. And of course, double false will be false as well. So the only time this ends up being true, one of those specific bits of discrete mathematics and logic, is when both of these are true, so we continue fighting. That's how we learn by mistakes. You can't make mistakes, can't learn. That's all. That's all. All right, so let's get back to it. That was a funny one. My logic. I'm still waking up. Hold on, let me get my coffee because logic requires a lot of caffeine. Hold on. Mm. Oh man. All right. All right, cool. All right, so let's do battle, but also let's make the console pop up because I want to make sure something happens. Hey, looks good. All right. Cool. So now 95, 95, 90, 90, 85, 85, 80, 80, 75, da 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 da. Now we only have one person that gets down to zero, which means the other person is probably still alive. But we don't have a kind of condition for the victor. We haven't said, oh, player two is the victor, player one is the victor. So then, what do we do? Well, after the battle loop happens, or really the outside here, after the battle loop for the while, we can check to see who has hit points remaining. So if player 1 dot hit points greater than 0, console.log, player 1 is the victor. However, if the other case scenario happens, you'll see a specific thing happening here. Oh, no, it's daytime, technically. I'm in a different place in my life right now. I am in Europe. If hit points 0, but I do work on US hours with US students, so I end up waking up like noon my time and staying up until like 4 a.m. my time, which would be basically 4 o'clock in the morning US and then like 8 o'clock p.m. US based on literal work hours. It's the remote work life. What can you do? Player two is the victor. So now we check at the very end of the battle who is the victor, who has hit points greater than 0. Now we can refresh. We have a nice little victory at the end. Player one is the victor, still has points left. However, player one's the victor, and we do it again. Player one is the victor. We can keep fighting over and over and over and over and over. Fair enough. Yeah, yeah. I'm in Eastern Europe, so it's like not too far. It's like what, 7 hours backwards for you guys? 6, 7 hours backwards or so. Right now it's almost 2 o'clock p.m. So you must be in the morning time. So no matter how many times I play this fight, it's always the same victor. Well, this is like playing tic-tac-toe. If you have the knowledge to place yourself as a player one in the best place location, you can always win no matter what. Player one has an advantage in tic-tac-toe, and player one has an advantage in attacking first. My current profession, basically, I work at Stigme. I mean, you can basically find me on LinkedIn. So if you go to LinkedIn, my profile, I have basically my full resume there. Currently I work at Stigme Learning, so I teach kids all around the world mathematics. I've been doing literature lately too, reading, sometimes programming, depends on the student, but very seldom programming nowadays. Um, Before I used to work at, well, I kind of self-employed here, right? But Stigme Learning contract. I used to do a website for a friend of mine, be his developer. I do private tutoring and lesson face. I worked at freaking Take Lessons for nearly 15 years until Microsoft bought them and basically shut down the whole website. That's pretty messed up. I had a lot of students there. It was a great job. Um, it was awesome. But I mean, generally speaking, I've always worked in the education and tech field. I worked at High School on Demand, Excel High School. I was an IT journalist way back in 2015. I went to Taiwan. I met with ASUS, Acer, and a couple of other corporate CEOs and stuff, and basically did, well, I wrote for TechWare Labs. So if you go to techwarelabs.com, and then I think you go to author Christoph, and I'm probably still there in the front anyway. You'll find the things that I've written there. So that's way back in the day, though. That's like 10 years ago. I worked at Valencia Community College. I worked at University of Central Florida. So, I mean, I guess what's my current profession? It's essentially educator. But I also worked as a product advisor in tech at Microsoft, Apple, and just continuously. So you can check that. That's on my LinkedIn profile. Anyway. So now we have a set of details here. We have player one is the victor, but we've ran this battle simulation multiple times, and player one is always the victor. That's the problem. Because there's no dynamics to it. There's no random set of chance, there's no blocking, there's no accuracy miss, there's no critical hits. Basically, we're moving by fives based on the attack given to us by our class, right? The attack hit points, attack damage is five, and we're just constantly just subtracting by five. Now we got to make it a little bit more dynamic. We got to make it a little bit less predictable that player one is always going to be the victor, no matter how many times we press the simulation. So this is where we start incorporating next set of variables. We have defense. Won't be too crazy. In this case, defense won't do much. It'll just make our fight from 5 to 3. Unless we now include items and then set an array of items and basically have a shield, have a sword, have all these armors and bits and pieces that will affect our existing stats, right? So that's another case to consider to expand it. We're not probably going to go that far. We're really just going to the point of understanding how classes act, but that is a case for us to expand on if I make this a little bit more dynamic and advanced in the future. But the most important parts are actually going to be accuracy and critical hit. This is where we leave things to chance. Chance is going to change the way this game is played, the simulation it's run. So when we do an attack, we got to do some dice rolling, basically. If you ever played Dungeons and Dragons, we got to use something called math.random. Math.random is going to be our key to making a dynamic, ever-changing, based on chance situation. But first, we got to understand how it works. So let's take it over here, math.random. We can test it straight up in the console. Math.random, math.random, math.random. Notice it's always between 0 and 1. Very useful, actually, because it's customizable. Math.random basically gives us a random value between 0 and 1, just like typical statistics and probability. It's a fraction between 0 over 1 and 1 over 1. It can be 2 over 5, yada, 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 right? You just can't have a numerator larger than the denominator. But this gives us a very good aspect to the next step. We basically state, hey, if accuracy is 80, we're trying to figure out a comparison. Is our math.random ever going to be greater than 80? If it's greater than 80, we're going to call it a miss. So in order for accuracy to function, we always got to call it underneath the value. So if it's within the range of 0 to 0.8, that's when we hit. If it ever falls above 0.8, we miss. And this is where that happens. So if math.random is less than, in this case, player one is the actual activator here. So player one dot accuracy, then we do a typical attack hit. It hits, it lands on the player. However, if it doesn't, we do a little else, and we say console.log player one missed. And essentially same logic on the next step. We do it for player two this time. Player two dot hold on, math.random is less than player two dot accuracy. And we throw it here. So if it's within the bounds of the accuracy of 0.8, so basically if that value generates any number like we saw here, this would be a hit, this would be a miss, this would be a miss, hit, hit, uh, hit, miss, miss, hit. You can kind of see how that works now, right? So this is just going to happen within this specific check. It's going to continuously check every time we do a fight scene or anytime the case is that player one is alive with greater than 0 hit points and then he's about to make a move. We're going to check real quick with some random chance to check and see if they're going to make that hit. And of course here, else if it doesn't, player two, oh, hold on, console.log Player 2 missed. Now we have given it a random set of chancing. Now battles will actually be a lot more dynamic. Player 2 is the victor. Player 2 has 10 hit points, player 1 has 0. Player 2 is the victor. Player 2 has 15. Damn, he lucky. Player 2 again, lucky. Player 1, 40 hit points for player 1 on this case. Now we have what we would call an actual accurate, if not pretty decent, simulation. Player 1, player 1, player 1, player 1, player 2, player 1, player 2, player 1, and so on and so forth. You get the idea. Then we have the application of criticals. Oh, that's just another if statement process forward. If we do land a critical, so if we do make a hit and then we have another math.random case where the math.random is less than player 1.critical, we have two hit types. So if he is within the bounds, the 0 0.1, so 0 to 0 0.1, if math.random is less than 0 0.01, then we can say console, console.log player 1 hits for critical. And we gotta adjust our player attack with a little bit of math. This is why math really does pay in gaming. We gotta multiply the attack currently with a parenthesis of the combination of 1 plus player 1 dot attack times, well, hold on, that's critical chance and then critical damage. So chance should be this. We've got to adjust this a little bit because there's two critical values here. Critical chance, 0 0.1, and then critical, what is the word I use for it? Yeah, dude, that's basically how Pokemon works, dude. You can make your own Pokemon game directly by doing this sort of format. And it's all about how you apply these little values, right? These little pieces. We haven't quite gotten to the full structure of, like, objects and how we can now make this battle scene because we've just about finished the battle scene. Once we finish that battle scene, we'll literally apply it to the class. So the class holds all the logic, which is where we start using this keyword. And hopefully if you've been with me for this long, for this session so far, knowing the code we're working on currently, it'll be pretty easy to basically see how I'm going to apply this as an object conversion. If you haven't, if you just dropped in, make sure you do go back and take a look at how the logic works, because that's going to be really the key to understanding how classes and objects change outside code logic to what we're going to do, create a battle scene inside the class itself. That's the key. So being able to be inside of the class is slightly different logic than being outside of the class because we're kind of just using player one, player one. We're going to make some adjustments. We got to use this keywords pretty often, but we'll see how that works in a moment once we get there. Okay, back to critical. So player one dot attack times. Now we got to take the attack, multiply it by the player one dot critical damage, which means amplifier, which means this is a value I need to create inside my class, and the amplifier is going to be a what, a 200%? So 2 times 2. So when a chance happens, we multiply, no, we don't need this part. I was thinking of a critical difference. No, that's fine. So minus the critical player attack, whatever it is, with the amplifier times 2. And then if this person is holding any item that would essentially increase that critical amplifier, then we can make adjustments to it also within the class itself. So this value is changeable, and we can do that within the class with some kind of equipment update. You equip a new sword, change the values. Right now, we don't have any adjustments yet, but a function will handle that for us. Just like we're about to make a battle scene function to actually handle this fight scene that we're building here, we can also make another kind of update equipment, equipment stats. So anytime we pick up an object, we will basically run this function to update all of these stats based on those items we just picked up. Cool. So let's see. If any major issue will come, I will tell you in the next stream. Sounds good, man. Sounds good. You're gonna come with a lot of debugging. A lot of debugging is gonna happen. Also, if you set up an AI locally, I don't know if you have a graphics card to handle it, but remember, I had a session on how to set up a local AI with Olamo. You can just kind of go to your terminal, run your local AI, and then basically say, hey, create a player class object fight scene between player one equals new player and player two equals new player. And then boom, like magic, AI comes in with the W, the big W, right? Right? But then I didn't really tell it to do it. It's doing it in C actually. It's doing it in C++, so it might not work. And I gotta be like, wait, hold on. In JavaScript, please. And then it's gonna do the same thing we're basically doing now. Now I haven't talked about a constructor. Here's a function for the attack process. We're making a whole battle scene within that player concept. But then again, it might be a little overkill. Maybe just one attack function would work fine. We'll have to refactor the code appropriately. But that would be the more advanced case scenario. You'll notice that the this keyword is starting to be used. There's also this kind of quick minus equal this power, right? We're kind of doing it not in that shorthand, but we're doing it in the longhand form. We can actually just do this uh, minus equal right here. And that'll essentially shorthand this one line to the same exact logic. But we're taking our time. I don't want to kind of layer too many confusing factors in here. But again, if you haven't had if you don't have an AI set up locally, I recommend it. And you can look it up. Can I do thing? Yeah, I think Copilot can also work with this. The Copilot can actually work with the code generation, and I think it can essentially look at your code as well and help you out with that. So definitely try it out. Personally, I'm super private on the data case. I'm not a fan of Copilot. I'm not a fan of Recall. I'm not a fan of Microsoft, to be honest. I still use it because everything else in the world is this, but I've started to use my Linux a lot more lately. Mm, but I prefer something like a local model because this is completely local to me. And if I ask, let's say, Copilot to do something that's not necessarily nice, I can basically get in trouble. But let's say I do my own Llama, Mistral Nemo, a special coding um, type of model, and I say, hey, how to create a Python reverse shell server and client. So if you know what this is, well, this is not just your typical coding. This is now going into like, I don't know if I can explain it, if YouTube is going to censor me or not, but this is now code that will help you with some more explicit set of processes that you can use. So I love the fact that I can do this completely locally on my computer without it being, eavesdropped and data impaired by, because normally this would be like, oh, we can't do anything that's particularly harmful or exploitive of code. That's what they'll tell you on those sort of like connected applications like Grok, ChatGPT, Copilot. Oh, this code is too malicious. We can't give you this code. But I'm like, well, I can do it on my own with my local. They don't care. So that's a big key on the limitations that you have with the power of the AI. If you're using any of the public models, they're going to be completely watered down. Completely watered down. Dude, yeah, you can run this particular one. Get the Mistral Nemo. You saw me run it right here. Mr. Nemo has actually been an amazing, it's basically fine-tuned to be a coding machine. So Mr. Nemo, the Olamo AI model locally, I think it's like 5 gigs of RAM, maybe seven, and that sucker can give you some crazy code without any questions, without whether you're using it for good or for bad. Even if you're just trying to learn how to do stuff, you want to understand how things work. It's not censored. It doesn't keep track of data. So good. So good. So Mr. Nemo, definite recommendation. Anyway, great guides that you can have at home when my stream's not up and running, right? So if you don't have this AI up on the screen, you can get your own on your computer. But check this out too, because I do have a video on that, right? If you go to youtube.com, oh, I think you can do Chris MIA Olama. No, you find a lot of them on here. Oh, I'm not even up at the top. QQ. Well, I have one. You should watch mine because I'm awesome. Right, guys. Right, guys. Ooh, 269. Nice. If you go to my channel and then look up Olama, hey. Oh, maybe it was a DeepSeek one. It was a DeepSeek. I didn't put Olama in the title. That was my fault, actually. Yeah, so if you look up the DeepSeek, you can actually get a DeepSeek model that's not connected to China. India, I know you're listening. You don't want to be connected to China. You and I both know why. Everyone knows why. So you can get a DeepSeek model on your computer that's not connected to China, but it's basically using the Olama application. Everything's run through the terminal. I got the commands in here, the models you can use, etc., etc., etc. And installing models, just basically do the Olama space pull space Mistral Nemo, the model I just ran here. Once you do, basically replace the run with pull, and it'll download that model on your local machine, and then go from there. I know you know what I mean. No one really. China's a little no comment. So there you go. And then I also played around with DeepSeek on different cases. You can see kind of like it making websites, like actual websites, templates, bootstraps, all kinds of things in there. So always good to work with that. Back to the meat and potatoes. A little break doesn't hurt from time to time, but it's a break of tech. So I love talking about tech regardless. So, player one missed. Cool. We have a randomization. We've got our bits and pieces. What was I doing? I was doing critical hits, right? Critical amplifier. So we multiply the critical amplifier, but then we have to basically, oh, right, I didn't do the other case. So if math.random is less than the zero point 0.1 critical hit chance value, we do a critical hit. Or we really just do a regular hit if it doesn't work. So I just kind of do boom. Now we're kind of getting a little extra text happening here. We're gonna have a very clear one. We can also do a couple of values, right? For normal damage, sure. Uh, for plus player, what is it? One dot attack plus damage. So we can actually say the amount of damage that was done. So 5 in this case scenario. Then here for critical, we can do a little bit of a splicing in between for the value of. See, this is where I really don't like copying and pasting these long sets of code, even though it's just one thing being activated. What I will do, I just take this out, go over here, make a new variable, let damage crit equal this, and then just use damage crit instead of making my whole code ugly AF, right? Here we don't want critical, so we remove it. Always clean up code. Yeah, no, China is sus AF, dude. I mean, I don't know what they're trying. I mean, I do know what they're trying. They're trying to replace the US and the global market, and they did a great job flooding the world with cheap products. And we can talk about geopolitics, markets and stuff, but my goodness. Uh, I hope their real estate really does come back to haunt them. Let me just say that. Okay, so console, otherwise player missed. All right, so you got to miss if the initial if statement of math.random accuracy. So if we failed an accuracy check, console, the player misses. If we don't fail the accuracy check, then we make another check for critical chance. If we succeed the critical chance, we apply a damage crit. If we don't, we just do a regular damage attack. And of course, we adjust a little bit of the interface so it tells us a little bit more details. That's for the first player. But also notice we're getting to a point, and this is why I always say when you have to like copy and paste and redo the same set of code, now we're getting to a point where we can use a function. We can now say, hey, isn't this the exact same thing that player two is going to apply? And then we think, wait a minute, why would I copy and change and basically go through the process? This is a perfect time for me to go, hey, well, let's let the class handle it. And now we dive in. So, case scenario. We are checking player one hit points, player two hit points. We gotta go back a little bit in the logic. If we're checking these hit points, we have player one and player two here. Cool. Now, maybe battle scene may not be the best factor here because player should kind of handle equipment. Like we can kind of fit it in here, and then it's like player has a whole battle system in it. But like if you think on the bigger, grander scale of expanding your actual game into something feasible, not just an example like I'm doing, is you would also create a battle class because that in itself is different, right? That in itself will handle different types of pieces. Sure, you've got player one and player two working with some certain values, but now we want to make sure that battles have a type of arbitrary external factor. So I'm not going to create battle scene. We're going to really keep the player class specific to the player, right? Just like the lamp doesn't have um what the heck's that thing called that blows up and you can't use the power until you replace it? Oh, God, words. Transmission is not the word. That thing that would be like the failsafe for your power to cut off whenever like a surge happens. Every single fucking horror game has this. What the hell is it called? Now I'm confused. You probably let me know when you figure it out. Anyway, it's like the lamp itself doesn't have a power generator. That's a whole different object. So we want to really isolate logically, accurately, the two different pieces where player is its own and where battle is its own. Battle can use player though, because we're going to program that sort of interactiveness to it. So I really do think in this case, battle is the better choice instead of having to have a much more complicated non-player related details. Object orientated, as I said in the very beginning, is an opinion. You do not have to code like this. But if you want a job in a big company, sucks, you do. But the logic here is that we create that object orientated mentality. So, and this is how you can tell a person specifically by the way they code. When you look at what's that guy's name? Pirate Software. When you look at his code, from my perspective, you want to shit yourself. It's an absolute mess. Did not get rid not the thing of player and battle. Okay. So when we look at the fact class player, just like lamp, right? If you look at your lamp on your desk, that lamp is connected to the wall. It's still interacting with its environment. That wall outlet connected to a power plant. I wouldn't say that that lamp has the ability to control that power plant, right? Because it doesn't. They're two separate things. So there's no reason for class player to control the battle. This is again more of an opinionated form of programming. You pick your logic and you can create the battle scene inside of the player class if you'd like. But the logic behind this is you may run into certain cases where it backfires. I can kind of see them already. It's hard to explain. But when one player is managing that battle, what about the other player? When do you use player one's battle versus player two's battle scene, right? You have two battle scenes now in two objects. When do you use which one? Now it becomes a little bit redundant to have in two locations. That's why having battle here gives us a centralized place. This is our power plant. This is our lamp. Two objects, they will work together, but they accomplish two different things. A power plant can also give electricity to your TV, but that's not a lamp. to your computer. That's not a lamp. Well, technically arguable. It's a screen and it projects light, but you get the idea. To your fridge, to your AC unit. So a power plant is a bit more over-encompassing. A player is just one single person. And what if you have now NPCs? Okay, say both are different scenario or class, but battle can influence player class, but player cannot. In a way, yes. The way I'm gonna code it is players should not have the ability to influence the battle. That's actually more of a security risk too, if we really go down the line on effective programming. A player class shouldn't really have the ability to judge a battle. It should just give the stats and rules of that particular one player, and then the battle will make the judgment. And for security's sake, the battle will be the one making the calculations. So if a battle is on server, like this is a case for like a server client base, battles will be held on a server, but a player is going to be held on a client. So you don't want the player on a client that can be hacked like Roblox to manage that battle. You get what I'm saying? You want the server class battle to be officially registering what each player is doing globally between two different Roblox accounts. You don't want to give player two on one Roblox account information to player one on another Roblox account. So that's another kind of bigger picture to look at on the networking scale. So you don't technically want, I mean, we can build it that way, it'll be fine. But as far as quality of code, expansion into a bigger project, you're going to have to refactor if you decide to do that. As an example, I could easily go forward and just say back to what it was, battle scene. But that battle scene would be managed by player, and then player is going to be made on that particular machine. And what if I export this to Roblox or any other form of bigger system? Then we really do have a problem because we kind of want the server to manage the battle. We don't have a server client process here, but the logic still stands that they will be separate. So we do eventually have that logic in the future if we decide to expand that way. Cool. So from this case, I basically will do, well, this factor is too involved in a battle. Think about it. Terrain, right? You can have, if you're doing Pokemon, right? There's some factors that don't really happen with player. There's water, right? Land, right? Air, mountain, power plant for electric, whatever. There's actual influences that a battle can take or have when it comes to the actual terrain. We don't have that particular, we can, again, stick a terrain in player, but now we're getting messy. Now we're getting extremely messy with our process. But in the battle case scenario, your scene, your terrain can influence fight mechanics. So that's another case to really separate battle from player. But really, what we want to do is we want to create the actual battle scene. And it's going to be between, and this is really the key why I'm doing it, it's going to be between player one, player, oh my gosh, hold, what am I doing? Player one and player two. The input for both of these individual players can now be pressed into this battle scene. Okay, well, from this point forward, hmm, a little bit of adjustments that can be done inside of here based on the damage at least. At least a player can do a damage factor. So we can technically, piece by piece, player one accuracy, if met, rah, 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 player one, this, player two, damage crit. Okay. Attacking player one, player two. I don't want to make this a little too chaotic, too crazy back and forth movement. But attack outside of battle scene, I mean, really from this point, we can basically do this and throw it in battle scene. Because we still have the same variables being used. We call our battle, let player one, we have to make sure our variables are called before the battle. Hold on. hold on. Something's not closed right. Hold on. I didn't do a good copy here. Okay, that's a better copy and paste. Then I can right click format document so it cleans it up a little bit. All right. So player one, player two, and then let battle scene equals new battle. And then we can activate battle dot battle scene with player one and player two. We can always optimize it even further. So the values will go forth and nothing really changed here. We just organized our code to be a little bit more object orientated. Other than battle scene is not a function, battle scene, terrain, battle scene. It totally, oh, wait a minute. Oh, I'm naming it weird. Double battle scene here. So let's say battle. I'm naming things a little bit less, but let's say battle scene, battle scene, battle scene. Psh, a little bit weird, but naming conventions, they can get a little buggy sometimes or ominous. And we have the same logic. One Victor, one Victor, one Victor, two's Victor. Just checking the logic is still functioning correctly, and it is. So far, so good. So now we've let Battle Scene manage this, and it's a pretty intense thing, but we also haven't kind of gone to the next step here, which is where I'm starting to really take a look at the kind of logical structure. So I'm seeing this for player one, and then I'm seeing this for player two. They're essentially the same thing. The only thing that changes is that player one gets replaced with player two. But the logic ends up being exactly the same in the end result of things. So this is where my refactoring organization happens to start. I can basically condense this, and this is a attack. So we can technically, logically, put a function. Where's player? Where did I put player? Did I condense it? No, right here. We can technically make a attack value, attack function. And then we will want to essentially describe who's attacking to what. This is really where we can actually drop into the this keyword. So player one attacks another player. That player that's going to attack, going to be attacked technically actually, is going to be in the input. So target. Okay, that's step one. Now, when I'm thinking, and I'm probably not going to erase anything yet, I'm going to take this because this is the logical loop that or the logical condition we're going to do twice. I can technically paste this over here and we still, because this is built with critical, with the accuracy chance, right? This player two doesn't have those functions yet. It just kind of has your typical base stuff that we started with. We have an updated player two to have these sort of features, but this is the point where you're like, wait a minute, player one has all these features, but now I got to give them to player two. Can't I make this universal? Can I make both players have this ability without having to double dip and copy and paste the exact same code and then figure out what has to change? Yes, the better choice is again, find a copyable set of code and then bring it into its own function or a method. And the method is basically a function inside of a class. Attack is a method. But notice that even though it's being created like a function, it doesn't have the function keyword. Battle, right? Here. And then we have function parse here. So those kind of key values are basically the only separating factors. A method is called a method because it's inside of a class, but it basically is a function. It's just without the function keyword. So it's like a function class player that has our current attack logic to make things simplify. Yes, exactly. That's the one thing we can do. While we don't want the whole battle scene to be managed by any player specifically, we can give each player the ability to attack. This actually does still fortify security when you're trying to make accurate representations in a gameplay. Because you don't want player two to influence player one's logic, right? So this is where you start seeing this one thing start to happen. Right, exactly. So the target is going to be whoever is being selected to attack. And the way we're really going to do this, we're going to take all of this and we'll say player one dot attack player two. That's going to be the logic. That's going to be player one activates the method attack on player two. Now, here's where the mind bend happens. Player one is this for the current situation. For line 174, player one becomes this when we're talking about what happens in the function attack, the method attack. And that happens here. Player one doesn't exist anymore here. We're not importing player one. We're not importing player two either. In fact, we have to adjust player two to target because that's the technical player being activated on. But player one in our logical sense becomes the this keyword. So this happens here, this happens here, this happens here, this happens here, player one, player one, player one, and I think that's the last player one. Let me see. Yeah, when I double click, nothing else is highlighted. So this is the current target, or sorry, the current person in the fighting. My response is Gretty. Greety? Greety? Great? Yeah? Is it falling into place now? I hope it's falling into place. Target is now player two. Now we don't have to even think about it anymore. This logic fulfills everything we need. Not only do we have the logic for all of the critical chance, accuracy, amplifier, etc. Oh, maybe, yeah. I mean, technically, I think the response comes in maybe 10, 15 seconds when I respond to you. So from what I'm reading now, it's probably like 10, 15 seconds for you to get my response. And then when you send a response to me, it's probably about another 5 seconds. So maybe call it 20 seconds total. But that's normally how like streams work. At least I haven't optimized that case scenario. I don't know how to optimize the streaming process yet. Maybe I need to be a bigger streamer and I have higher YouTube DOD powers, whatever the case may be. I'm not sure. So we've adjusted the whole logic. Instead of player one and player two, we have this as the current value, the current person fighting, which in our case is player one for the line 147. Player one attacks player two. Player two becomes the variable target, and we just take the logic we created earlier and replace the values accordingly. That's why I like to code outside of the class first to get my kind of general logical structure understood and placed. And then when I see that chance to, hey, I got to copy and paste the same logic twice, then I can just say, instead of just making the same code twice, I'm going to make it reusable. And especially in this case, since I'm talking about a player that can attack, I'm going to make it reusable within the class itself. So this is a reference to whoever the current player is. That's why this keyword this, I'm going to say this so much and it's going to be annoying. That's why this keyword is so confusing because this is relative. The keyword this is relative to one, the line that it's running on, in this case 147, and the variable that's activating the attack. Player one in this case is this. I hate saying it so much. I just hate saying it so much. So player one is considered the this scenario. Player two is the target being inputted. All other logic stands still. Then we get that. Now I can kind of check it, make sure. I should be working fine. Da-da-da, da-da-da. Player attack is not a function. All right, all right, all right. Oh, wait, hold on. What? Attack player one dot attack battle player. Wait a minute. Uh-huh. Player one dot attack player one. This isn't the battle scene. So battle scene player. That's why I also take it a step at a time because I had to kind of patch in two different classes now. First, we created the battle scene. We put all the code and it worked. Always check it worked fine. So then we can keep going. After that, now I replace player one with, or the whole scene with that player attack, player one dot attack, player one battle scene coming from here. It should though. It should exist. Absolutely should exist. Let's check the code specifically. Attack player 2. Battle scene player 1. Player 1 will hold the attack. Unless I'd named it differently? No. Player attack. It's still within the bounds of the class. Hmm. Interesting. Interesting. So something between the two classes are getting a little. I think this is a JavaScript issue, honestly. I remember doing this, and there was a way to patch back and forth. This doesn't happen in like C, C++. Let me see. Player one doesn't exist though, unfortunately. This player one is inside of a function called battle. So let me do a little debugging by removing the function on the outside here. Letting them be global variables. And now I can actually peek inside of those variables when they are global. Oh, you know why? Because we have attack here as a variable, and then we double dip on the same keyword. Can't do that. So, okay. Ah, ah. Um, I can say damage, but I'm just gonna say attacks with an S. I'm just gonna change one thing instead of changing 50 things. So, preparing your particular keywords can help avoid conflict. All right, great. In fact, let me kind of get back on the function battle thing. And then go back here. Where is it? Where is it? Where is it? Attack, attack, change it to S. Attacks target. Yeah, I know. When things get extremely large, they get a little bit extra complex. All right, there we go. Now it understands. So, well, we don't know yet. No. Oh, right, because I didn't adjust the name attacks with the S at the end. I changed the function name, but attack player one is not the. Uh-oh. 127. Did I mess up a paste? I did. I did mess up a paste. Great. Okay, what else did I mess up on? Let's keep going. There we go. Yay, it works fine now. Boom, 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 boom. I want to make sure the randomness still works fine. Yep, it's still looking good. Now, after all that work and we just organized our code to look nice, neat, not duplicated, not copied, pasted all over the place, but now we have this function. Dude, now this can just be player 2 dot attacks player 1, and this is why we love classes. All that extra logical conclusion that I would have to have done before, copy that whole section from player 1 to player 2 to achieve the exact same thing over and over and over with player 1 attacks player 2 attacks player 1, back and forth, back and forth. We don't have to do it twice or three times or copy and paste it. Now we have a nice function that applies that code, and this is where you go, damn, that's sexy as fudge. There we go. So we've accomplished our logic. Now we should have a much nicer balanced battle between player one and player two. One's victor, two's the victor, hits for five, there's a miss, there's a 10 crit, there's a 10 crit, etc., etc. Then we can expand on this. We can expand on items, how the terrain might affect the player's particular values. Maybe water makes accuracy much more difficult, or maybe underwater, because this is on top of water, I'm assuming. Underwater, you have slower movement. Oh, we don't even have agility. Another case to put agility in here. Putting in agility will determine which player gets first to attack. Can I get the sample of this code to understand, or you can say to use it with different logic? Yeah, I can host it. I can host. In fact, hey, if you want, because I do have a Discord for gaming and all kinds of stuff, but this is basically where I have. If you want to join the Discord, I can send you the code there. Uh, let me see. So here, for those that have made it to this level, this ending point, this is gonna be kind of the end of things, right? So I'm gonna do that, I'm gonna do that, I'm gonna do that, I'm gonna do that. And I will go send this in chat for those that made it to the end. I wanted to do actually a couple of things with a lot of viewers. I wanted to work on basically playing on the Minecraft server I have. Wanted to gather a bunch of people from Minecraft, build up some villages. Here's my Discord. Join up, and message me there. Hello, welcome everyone. And I can consider this to be a kind of done for today. I think I'm kind of done with this process. We went through a lot of class-based object understanding. And this is kind of how we work with them. The logic of battles, the logic of how we use specific keywords, values, states, functions, so on and so forth. I will put this file, you can see it right here. Where's my stream space? I need to make a nice streaming space. Stream music, stream. Oh, yeah, there it is. Okay. Let's do stream code. Add that to the list. And then I'll drop it in here for you to use at your whim. Enjoy. And yeah, I think I think I will end it here, but the expansion can go on for a bit. We have this as our dashboard. Again, this is like literally the same project we started with on the workbench. If you go to, you can still use like things like the G for Google, cats and hats, right? Boom, enter. Then you can enter and go into a Google search, or you can change that to YT, cats and hats, and then you can do YouTube search real quick. So you still have the functionality. I really like the fact that we can take one project and expand on it to its full potential. We can make the project do whatever we'd like for it to do futuristically. And putting it all together, again, in the end, it's like your own portfolio, your own workbench. You get to customize it, work with it. We're going to be doing fetch in the future where we can go online and grab data from online sources. If we want to check the weather, we fetch it. If we want to check stocks, we fetch it. If we want to check basically access REST-based APIs. So what's a REST-based API? Basically a part of a page that waits for a fetch from someone and basically returns information. So you go to a URL, just like what we've done so far with our Visual Studio Code, or with our project here. We do basically go to search sites as we have them listed here. But then we can use a REST-based API instead of like a specific website and actually access weather, data, and it's using GET. Remember, GET is just the URL space. It's using GET requests or URLs to access information inside of those APIs. Whatever it is, it can be so many things. It can be data on populations, it can be weather, it can be all kinds of stuff. So that's a future project that I'm working on to get set. But in the end, classes was one of the biggest things because this whole thing is just classes inside of classes. When we're doing JavaScript or any sort of like when we're accessing 85%, remember how 15% is kind of the beginning of all languages, variables, lists, functions, ifs, whiles, etc. 15% easy. I mean, not easy, but when you get used to it, going from JavaScript to Python or Java, easy. The 85% is where object-oriented programming is absolutely necessary. Because for anyone that's creating a large, useful tool online, they're using OOP to organize it. This is a case for object-oriented. We had player one dot attack. Well, JavaScript has document dot get element by ID. Now it makes sense. There is a class somewhere that exists in Chrome that creates document. We can't use it or we can't see it. We don't know what's inside. But they're giving us tools just like our player has tools to attack. We might have a defense, we might have battle scene, whatever we have. Those are the tools that exist within a class. However, those are our custom classes. We can create our own, right? But for document dot get element by ID, this is that 85% that is created for us. We can't see how it's made, but there's a whole website to document how to use it. So when we create a gaming system, same thing. We don't have to let people see how it's made, but we can make a document online to tell them how it's used. And then we kind of wall it off so it's a little bit more secure so people can't look at the code sometimes. But open source is the best anyway. Okay, I've talked a bunch. I'm a little tired. I'm gonna go play some games. Thanks for joining. Appreciate you coming in, asking questions, joining me on my sessions on a daily basis. I try to do daily sessions with my office hours. So please do join, like, subscribe if you haven't yet, for further programming sessions when we're dealing next time, probably with the fetch. We might fetch weather information online and kind of scour the internet for possible things we can grab onto our local workbench that we're creating here. And again, if you do want this code, like Scary is at getting access to, join the Discord link that I sent in chat, and it's going to be in the stream code space. I've added that set of code there for you to observe, look at, copy, paste, whatever you like to do, edit, and start your own portfolio.